All right, so we'll keep our emergency parachute strategies in mind as we tackle our first topic here, which is polynomials. And let's start as we always do with the definition. For our purposes, let's break this word down. Polynomials. In the context of math, we're talking about many numbers or multiple numbers. And an example of a polynomial expression would be something like this. 2x squared plus 3x minus 7. I'm just throwing that out there, right? What we have here are three distinct terms that are not like. These aren't like terms. That's the next definition that we're going to talk about. What are like terms? Like terms are terms that can be combined. For example, if I said something like 4x plus 5x, you'd be able to look at that and say, well, 4x plus 5x equals 9x, right? I can add these terms together. I can't say that about these, right? I can't add 2x squared to 3x and get, I don't know, 5x cubed or something like that, right? And I'll be a little more strict about the definition. You can tell if two terms are like terms if they share the same variable and exponent. In this case, the exponent would be 1, right? So 4x to the power of 1 plus 5x to the power of 1 are like terms because they share the same variable and exponent. But here, same variable, different exponents. Let's try some problems involving polynomials. Pause the video and give these questions a shot. In the given equation, so this monster up here, c is a constant. If the equation is true for all values of x, what is the value of c? All right, well, this side is completely expanded, right? All the terms are laid out, and I can't combine any of them because none of them are like terms. But this side is all packaged up, all factored. So let's practice expanding that, right? Now, I realize that this doesn't fit our FOIL sort of framework, right? Because there are 3 terms in this parentheses instead of 2. But we can use the same idea as FOIL. We just don't have the nice acronym. What we're going to do is take the first term in one of the parentheses, multiply it through here, and then take the second term and multiply it through there. That effectively is the same thing as FOIL. That's what we're doing with FOIL. But again, I just don't have an acronym. Okay, so what I get when I distribute that in, there, and there, is I get x times x cubed, which is x to the 4. I get x times negative cx, which is negative cx squared. And then I get x times 8, so plus 8x. There we go. And then when I distribute this one in, I get 4x cubed, like that. I get negative 4cx when I distribute that in there, and I get positive 32. I'm sneaking into this other problem, but that's all right. Okay, and I'm not going to rewrite all of this. I'm just going to kind of bring it down here and say it's there, and those two are equal. Let's make our life a little simpler by getting rid of like terms on both sides, right? So for example, over here I have an x to the power of 4, and over here I have an x to the power of 4. I can subtract those from both sides. I have 4x cubed over here. I have 4x cubed over there, so I can get rid of that. I have 32 over here and 32 over there. Now let me write what I have simplified. Negative 5x squared minus 12x, boom, is equal to negative cx squared plus 8x minus 4cx. All right, so I have c in this term, but these aren't like terms because they have different exponents. But check this out. There is only one x squared term on the left side, right? And there's only one x squared term on the right side. And it must be the case that c is equal to 5 because nothing else combines with these on either side. I can't add, or subtract 12x from negative 5x squared. I have to stick with like terms. So it must be the case that c equals 5. And if I really want to double check this, I can look at the remaining terms, right? If these two are equal to each other, then this must be equal to whatever's left over. Let's make sure about that. 12x equals 8x minus 4 times 5 times x, if c is equal to 5. Is negative 12x equal to 8x minus 20x? It sure is, right? Because that is equal to negative 12x. One last word about this before we move on to the next question over here. Did you catch something interesting in the problem? Maybe related to one of the emergency parachute strategies we talked about? All values of x. The equation is true for all values of x. So we should be able to pick our own value of x, plug it in wherever we see x, and then just solve for c. That saves us quite a bit of algebra, or at least algebraic thinking. But if you didn't do it that way, totally fine. I'll let you try that on your own. Okay, let's jump over here, because this is another place where we can use the emergency parachute strategies. Which of the following is equivalent to the given expression if y does not equal 0? One quick word about this. The only reason this is really here, y does not equal 0, is because if y did equal 0, then the denominator of this fraction would be a 0, and that wouldn't be a real number, and we just don't like it in math, right? So that's why they say that. Basically, it's saying y can't be 0, but otherwise, knock yourself out. Now, this, as I said, is a case where we can absolutely use the emergency parachute strategy of choose your own adventure. Why? Because we have variables up here in the setup, and we have variables here in the answer options. Now, I will show you the algebraic way as well, but I want to start with the emergency parachute strategy, right? Why don't I just say that y equals 2 and x equals 3? Any objections to that? I'm certainly not violating any conditions that they gave me here. I'm just going to say what happens when y equals 2 and x equals 3. Well, let's find out. All right, so we'll plug in 3 wherever we see x and 2 wherever we see y. So we'll say that 3 squared, that's 9, x squared, 9, plus 2 times 3, right? So that's 6. 2 times 3 is 6. Plus y squared, which is 4, divided by x, 3 times what's 2 cubed? That's 8. Y times y times y. Plus y to the power 4, which is 16, right? And so when I add this all up, I'm going nice and slowly here. I'm sure you're probably zipping right through this already, right? I get 9 plus 12 plus 4. Make sure I have that right. Yep. Over 24 plus 16, which is 40. Nice and slow. This equals 9 plus 12 is 21 plus 4, so 25 divided by 40. And that, of course, can be simplified down. If I divide top and bottom by 5, I get 5 over 8. Okay, well, that's a pretty random looking number, but here's the magic of it. You ready? I'm going to take, as we did with the emergency parachute strategy, I'm going to take 2 and 3 for y and x respectively and plug them in. And whichever answer option gives me this magic number of 5 over 8, that's the winner. All right, so here it goes. X over y, 3 over 2. Nope, that's not it, right? Doesn't work. 3 plus 2 over 8. 5 over 8. Winner, winner, chicken dinner. That's pretty nice. Let's make sure, super sure, that I didn't just get lucky here and that these other two don't. So I'll do this a little more quickly. 2 plus 2 times 2, so 4, plus 4, divided by 8 plus 16. I'm just going nice and slow here to make sure that I'm not missing anything. Yeah. So that's 2 plus 4, 6. That's 10 divided by 24. I could divide top and bottom by 2, but that doesn't get me 5 over 8. Nope. Right? Right. Okay. So then here I get x, which is 3. Oh, I'm sorry. I realized I plugged in 2 for x. So that should be a 3. But it still doesn't work, right? Because I get 7 plus 4 is 11 over 24. No dice. Doesn't work. I keep mixing up my x's and y's here. Got to be careful about that. So if x equals 3, plus 2 is 5, plus another 2 is 7. There we go. Over 4 plus 8, 12. Again, no. So clearly, this has to be the correct answer. Now, as promised, I will show you the algebraic way to do this. But I want to stress that if algebra is not your bag, If you don't love algebra, this way works very, very easily. I realize it's a little bit of manual labor, but we can handle that. Okay, so here's the algebra of it. If you look at this and you're very good at factoring, you might recognize that this factors, the top, factors pretty nice and neatly into x plus y times x plus y. And how did I see that? Well, I saw that the first term is going to be x squared. I saw that the last term is going to be y squared. So a pretty good chance that if I factor it, it'll look something like this. And I can verify this by foiling it out and seeing that indeed it does give me what I need. Okay, and then on the bottom, I can do some factoring. I'll factor out what's the common term here, y cubed. So I factor out y cubed, then I'm left with x plus y. And the x plus y on the top cancels, the x plus y on the bottom cancels. I'm left with x plus y over y cubed. Either one of those methods will work.